number 34. Two boys are pulling a box across a horizontal floor as shown in figures 3-26. If F1 is 50 newtons and F2 is 100 newtons, find the resultant by graphical method and by the component method. Again, I'm not going to do the graphical method because I don't have graph paper, but I will gladly do the component method. Okay, so if we do what we've been doing before, I draw a starting point out here, and then I'm going to draw one vector, how it's originally drawn. So this is F1. It has a magnitude of 50 newtons, and it's at an angle of 30 degrees. And then we have the other vector, F2, which comes off of that at 60 degrees and has a magnitude of 100. Now, this is going to be very tough to do because I don't really have a way to add them together. They're at a weird angle to each other, and that's not going to work. What I can do is break them into their components, add their components together, and then work from there. So here's what I'm going to do. This 50-degree vector has an x component and has a y component. This 100-newton vector also has an x component and has a y component. So here's what I'm going to do. I'll do the x's first. So on my F1, my 50-newton vector, this is the adjacent side. So I know that x1 is going to equal the hypotenuse cosine of the angle. Same thing goes for x2. It's also going to equal the hypotenuse cosine of the angle. So I plug into my calculator 50 cosine 30, and I get 43.3. And I plug in 100 cosine 60, and I get 50. Together, overall, we have a total x component of 73.3 newtons. Since they're both in the same direction, I can add them together like I did, and I get the result. I can do the same thing in the y direction. I have y1, which is the opposite side, which would be sine. So that's going to be 50 sine 30. And then I'll have y2, which is going to be 100 sine 30. This up here, 50 sine 30 is 25. 100 sine 30 is 50. Oh, sorry, this should be 60. 100 sine 60. 100 sine 60 is 86.6. Again, they're both pointing upwards, so they're in the same direction, so I can add those two things together, and I get 111.6 newtons. Now, this is an x component. This thing up here is an x component. This down here is a y component. So what I can do is I can put them head to tail like I would build any other vector. So I'm going to start here. I have an x component of 73.3. I build on top of that a y component that has a magnitude of 111.6. The resultant is going to go right up like this, which if you look, kind of looks in the same direction as if I had put the resultant in the original diagram. So I did this right. In order to get the magnitude of this resultant, all I have to do is Pythagorean's theorem. So I'm going to square the 111.6. I'm going to add it to the square of 73.3. I'm going to take the square root of that whole thing, and I'm going to get that this resultant force has a magnitude of 133.5 newtons. If I wanted to get this angle over here, I could say that the tangent of the angle is the opposite side over the adjacent side. I use that arctan button, or the inverse tangent button in my calculator, and I find out that this is an angle of 56.7 degrees. And we're done.